Welcome to the Spatialedge AI show. So I'm your host today, Pierre, and we've got a guest with us who is a machine learning engineer, Therese Nieuwenhuizen. Hello, Therese.
Hello, Pierre.
Okay, cool. So Therese, we're going to dig a little bit in today in terms of talk about machine learning engineering, data science. We'll see what topics comes up. But before we get started, tell me a little bit about yourself.
Cool. So I'm originally from Johannesburg. I studied at the University of Pretoria, where I graduated in BSc Mathematical Statistics. I've always loved mathematics, the non-ambiguity of it, the logicness of it, all of that has always been a draw for me for many, many years. So naturally, when I graduated, I was drawn to the computer science and machine learning areas. So I found myself here at Spatialedge after a couple of months of looking for a job, and since then I've just grown in the industry. It's been amazing. I now stay in Stellenbosch and I love hiking and gardening. I find that it creates a lovely balance for the on-screen time that we constantly have. So, yeah.
So that's interesting. So you're kind of balancing the development all the time, focusing, because you also have meetings that is on the screen with people, clients in different areas, and then you're like, cool, I need to get away. I'm going to go either hike or do a little bit of gardening.
Basically, just completely switch off and detach from the online world. So I love that.
Tell me a little bit more about the gardening, actually. So are you interested in just different kinds of flowers and different plants, or do you also do a bit of fruits or herbs?
Definitely the herbs and fruits. So I find that quite rewarding with the gardening. So my husband and I, we stay on a farm just outside of Stellenbosch, and we have quite a lot of space to work with. So we've created this whole area where we've built planter boxes to grow herbs and vegetables, tomatoes, and then my favorite is chilies. Oof. And with the chilies, we actually like to make hot sauces from it. So it's a big passion of ours.
Oh, that is really cool. That's really nice. I thought I would like to taste it at one point.
I do need to bring some more to the office so that I can get some critique.
Yes. I think there's quite a few people who'd love a little bit of a hot sauce tasting. But yes, so you did the mathematics. You were quite deep into the mathematics, and then you started getting an interest in computer science and machine learning and all of that. And so you joined us. You joined us in 2019.
2018.
2018.
Yeah,
yes,
it's almost 4 years.
4 years.
Almost to the day, 4 years. 1st of November. So yeah.
It's been a while.
Yes.
So you've experienced the whole growth with the company as we progressed and as we went through different phases. So tell me, in the beginning, I remember, were you doing data engineering, or did you go directly into machine learning engineering?
I was doing what we called at the time production data engineering. Yes. I think that was before the world became like the term of machine learning. Yes. So production data engineering, I was the 13th person, I think, to join the company. So definitely a lot smaller at that time. But yeah, when I started, I was working with like Jacques and Frank and them on the productionizing steps of the data science models. So.
100%. I actually remember back then, like you said, it's even before Google came out with the term, I think in 2019, like years as a machine learning engineer. But before then, you're right, it was like, well, what is this thing? Because there was this gap in the market where you had data scientists at the companies, and they were developing different models, but they couldn't get into production, and so we started stepping into that role, and you then obviously started doing that, which is actually quite interesting.
It's been quite a roller coaster, because like my title changed a few times, but my work obviously changed and evolved. But it was like don't know what any of the titles mean, but it's so exciting because you're growing in an industry that is like so new. So
still finding its feet.
Exactly.
Do you remember back then what kind of was the first few things that you've looked at or took to production? Or
so the thing that stands out to me the most was I remember it taking about 20 working days to actually get a model into production at that time.
Yes.
Which is like insane when you think about it now, because we're at the point where we've created so many tools and capabilities that we actually have fast-tracked that to one day sometimes. If you provide the data scientists with the setup, then they can just plug and play, and then, immediately you can deploy it to production, which is so mind-blowing. With the work that we did, interestingly, that hasn't really changed, because I think Spatialedge has created such a good foundation of what we want running in production and what we need surrounding it. So we did have like schema validation and metrics and, some pre-execution checks and things like that. And that still is very relevant now, because you need to be able to track performance of models in production so that you know that it's still providing like, the correct results. Exactly.
Hectic. So out of interest, did you lean more towards helping the use cases and getting the models to production, or did you get more into the tooling and developing capabilities, or was it just like a mixture of both?
Yeah, a mixture of both over the years. But I think the most that I have done is helping the models into production. So sitting with the data scientists, cleaning up their code, seeing repetition or duplication across the different projects. And then usually from that, I will go and like help with the tooling and stuff, because you work with so many of these things that you can see how many like times things have been repeated and duplicated. So then you're like, okay, cool, this can actually be a functionality that we can harden and can be used across all use cases.
Yes. And then you also spoke a little bit now about schema validation, metrics, pre-execution checks, which maybe just to explore those three a little bit further. So the pre-execution checks, what does that refer to?
So that's basically just doing some checking before you actually run your feature creation or modeling or something, where you go and check the validity of the data that you're pulling in. Because there's nothing worse than you've created these features, or you're trying to build this feature store and then it fails because it's missing data from one day because that ingestion failed or something. So we want to catch that as early as possible so that we know exactly where the problem is. And you can set up alerts around that as well to go to the ingestion team or the data engineers, so they know, okay, there's a dependency for this table with this model. We need to go and see why this has failed and why that data is not available. And then they can proactively go and fix it without me having to go see it failed at this point. Why did it fail? Now I need to contact them. That takes time. So instead, it's like it goes immediately to the people that can solve it.
And I think this might be a massive, or could become a massive problem if you've got thousands and thousands of data sets, and then you've got all these models in production. And now if you didn't have these pre-execution checks, what would have, like you said, what would happen is, okay, this one model's failing. Okay, now I've got to start following the whole lineage of how this thing was built, and I have to look at all these thousands of data sets.
Exactly.
And it's like, that would be a waste of, well, one, it would be a waste of time, and two, oh my word, that would just suck.
No, it can be quite mind-numbing to have to follow that line down to find the root cause, because data scientists create features out of many data sets. I mean, we sometimes sit with one feature store that gets created by 30 different data sources. So now to go and track that down to find where the problem is, especially if they're joining on the data sets. Like you think it's this one, but then it's actually this one. Yeah, so something like that really just fast tracks finding where the problem is and fixing it. So.
I'm actually thinking now, so from my computer science background, a lot of the biggest problems is usually around dependencies and things being what they call tightly coupled. And like in the data world, like you just now actually was referring to, it's pretty much everything's dependent on the data sets. And so I love that this is like a great way of just having a good mechanism in terms of tracking, finding, and fixing issues, because you've got to manage all these dependencies. And then I'm assuming the schema validation is a similar thing or mechanism to check if something went wrong.
So sometimes like I think that was very big in the beginning. As we grew, it's somehow not as important, because sometimes you're manipulating the data where you're adding new features in or removing features, but it's basically the same thing where you're just validating that the data that you want to train on is still in the same format that you expect it to be. Because like if you're now going from like floats to integers or like something like that, that could have an impact on the model that you're training. So
no, 100%. Oh geez, imagine like or for example, if let's say one of the columns does change from like a float to a string because somebody introduced some weird error, or like
now you want to do a calculation on this thing and it's like, I don't know what this is.
The thing just breaks.
Exactly.
And again, then it comes down to, well, if there's thousands of these things and all of them are integrated and there's like this whole flow, and it could then potentially even affect other or 10, 20 other models, which is in production, which is making money for a business. I do not want to be at the end of that kind of conversation if they only discover that like 4 months later or something.
Because of one column that changed its...
Because one column. And
How do you explain that?
Oh, terrible. But I mean, I guess this is like one of the fundamental things about the value of machine learning engineering.
Yeah. It's finding out where it can break and trying to stop it before it gets too far.
Yes. So. Yeah. You've got these things making you money or saving you money in some way. Now, how do you make sure this continues? And that's one great way, because things are going to fail. I think like things change all the time.
No, it's this, you can't not have it fail, you know, and if you try and optimize it to not fail, then it's kind of like, is it even producing results if it's not failing? Because like if it's changed now, but you've created it so that it will never fail, are you even getting the results that you want? So you need to like just make sure that when it does fail, you can easily find out why and fix it.